Hey everyone, and welcome. On behalf of Forge College, I am absolutely thrilled to jump into today's explainer. We're picking up right where we left off, so moving straight from our previous lesson on mapping conditional deployment flows, we are diving deep into the Access Control Patterns course. Today we're building our very own digital vault, implementing Ownable in Solidity. Basically, think of this as taking all that deployment theory we just mapped out and using it to bolt a massive, impenetrable steel door onto our smart contracts. Let's get into it.
Okay, let's quickly run through today's architectural blueprint. First up, the blueprint concept. Second, state and the constructor. Third, building the onlyOwner modifier. And finally, compiling and deploying locally.
Section 1. The blueprint concept.
You know, by default, a smart contract on a public blockchain is radically open. Literally, anyone can interact with it. And a contract without an owner is basically like a building with no doors and no locks. Anyone can just wander in, rearrange the furniture, or, worst case scenario, completely empty the cash register. So we absolutely need a single owner model to enforce exclusive permissions. To pull this off, we rely on a globally available variable in Solidity called msg.sender. Think of this as an unforgeable ID card. It's the ultimate VIP golden ticket that the Ethereum network hands to whoever is currently knocking on your contract's door. You can't fake it, you can't alter it, and fake mustaches definitely will not work here. It is our absolute source of truth for identity.
Moving right along to Section 2, State and the Constructor.
Let's lay the foundation. It's actually incredibly simple yet so powerful. First, we declare and address public owner variable. Now, making it public is a very deliberate engineering choice here because it automatically creates a getter function. That allows for really easy off-chain inspection. Because hey, if you're building a front-end interface, you want to easily query who the boss is, right? Then, right below that, we ink in our constructor. A constructor is just a special function that runs exactly one time at the exact moment the contract is deployed. Inside it, we set owner equal to msg.sender. In plain English, we're taking the digital ID of the person who deployed the contract and writing it down in permanent ink as the owner. We've officially created our VIP list, and it only has one single name on it.
All right, Section 3. Building the onlyOwner modifier. So we've got our VIP list. Now it's time to hire the muscle. In Solidity, a modifier is essentially like a wrapper you can snap around any function to change how it behaves. Our heavy-duty bouncer here is the owner-only modifier. The logic is beautifully straightforward. We use a require statement that says require msg.sender equals owner. The contract simply looks at the ID of the person calling the function and checks it against the one name on our VIP list. If they don't match, boom, the transaction reverts immediately. It tosses the imposter right out onto the digital pavement with a really clear error message, Ownable, caller is not the owner. But what if the IDs do match? Well, check out that little underscore and semicolon at the very end. That's basically Solidity's way of saying, right this way, boss. It steps aside, letting the legitimate owner pass through to execute the rest of the function.
And here is how we actually put our new bouncer to work on a sensitive, state-changing function. Take a super simple counter function. All we have to do is add our owner-only modifier right into the function signature, literally, just right after the word public. And because of that one single word, nobody else on the entire blockchain can successfully call this increment function except the exact address we saved in the constructor. It is completely, securely gated.
Which brings us to Section 4, compiling and deploying locally.
Because, let's be real, an architectural blueprint is just theory until we stress test it in the real world. To bring this code to life, your engineering toolkit gives you two really great options. If you want super fast, immediate verification without messing with any setup, you can just paste your code into Remix and deploy it on a browser-based JavaScript VM in seconds. It is incredibly satisfying for a quick check. But if you're gearing up for a production-ready application, you are definitely going to want the locally reproducible, script-based workflow of Hardhat running straight from your terminal.
Whether you decide to use Remix or Hardhat, you are looking for 3 concrete checkpoints for success here. When you go to test this yourself, watch for these exact outputs. First up, clean compilation. Absolutely no errors, cleanly yielding your ABI and your bytecode. Second, an allowed state change. When the deploying address calls that increment function, that counter variable absolutely must go up by 1. And third, which is honestly the most fun part to test, the hard rejection. Switch your active account to literally anyone else, try to call increment, and just watch that transaction revert with your custom error message. If you had all 3 of those checkpoints, congratulations, your vault is secure.
Let's wrap up our handover today. Try to keep these 3 core principles of the single owner model in your back pocket. Number 1, state visibility. Making your owner variable public gives you incredibly easy, testable proofs of your deployment state. Number 2. One-time initialization. The constructor locks in that initial authority at the exact moment the contract is born. And number 3. Function-level enforcement. Modifiers give you a really compact, reusable way to enforce access checks over and over again without cluttering up all your core logic.
But all this raises a pretty fascinating question for us to ponder. What happens if the owner accidentally gets locked out? Or what if they want to sell the protocol and just retire to a digital beach somewhere? A single hard-coded owner can very quickly become a massive single point of failure. And that sets us up perfectly for our very next lesson on ownership transfer practices, where we're going to learn exactly how to safely pass the baton. A massive thank you for joining this Forge College Explainer. Be sure to head over to forge.college to learn way more about this and tons of other incredible Web3 topics. See you in the next one.